All right, everyone. Hello and welcome to our first session today on Intro to Cloud. Super excited to have you all today. And I'm sure you're all excited, maybe feeling a couple of different emotions, maybe happy, nervous, scared. Either way, we're going to get through this together. Just wanted to make some quick announcements here. So, to make sure we have a super smooth and successful day today, I'm going to ask that you all have the training site open. You want to be logged in and open, as well as having Slack open, because we will use the live chat today. Um, and for to have like the best experience with Codio, which you will access on the training site, you don't create an account, right? To have the best experience, we've found that Google Chrome works best as a browser. If you have Google Chrome as an option right now, I would suggest logging in through Google Chrome. If you don't right now, that's okay. Other browsers work, they just don't work as well. So I would say use what you have today, but moving forward, I would strive to have Google Chrome as your main browser. And I will also, I linked it in the official announcements channel, but I will also link it again in a bit. And all right, let me just see if there are any comments here. Oh, good question, Brianna. TAs, yeah. So the majority of the TAs, about 14 of them, will be in every single class. And on some days, we'll have 16. All right. Other than that, I think we are all excited and pumped. So I'm super excited today because we have Bill with us. He's super excited to teach you all today. I introduced him on launch day and I don't think I did him justice. So I want to turn it over to Bill right now for him to introduce himself and then to get us started on Intro to Cloud today. Thank you, Bill.
All right, thank you, folks. Thank you for start of this class. It's going to be a great sets of sessions coming up. Everybody can hear my sound okay. My video is okay too, right? Oh, good. So I'm going to share my screen. I'd like to share lots of stuff. So let me share my screen here. I'm going to bring up just introduction. Any questions or comments, we can take those. Just so you know, my background, lots of examples are used throughout this curriculum. So I want to clarify where I'm coming from and my background in the IT world. And so again, privilege and an honor to be teaching this topic to you great folks. It's going to be quite riveting. There's going to be lots of concepts we're going to address. We're just going to make sure everybody's understanding all the concepts as needed. I usually tell everybody, if I can do it, anybody can. It's just how you learn. Everybody learns at their own pace. So we want to make sure things are as needed. Let me just make sure my Slack is visible. And Catherine, which channel should we monitor for live chat that's going on?
Yeah, the live chat channel on Slack.
Oh yeah, live chat. Okay, good. I have that open. So I like to engage a lot of folks. So when I'm covering the topics, I'm going to ask a lot of questions. So by all means, keep that live chat channel on your Slack open, and then the channel stays open even when we're ending the session. And we go on to the other section. So just my expertise, over 25 years in the field, you know, every role that you can think of, I pretty much handle. And make sure my marker right. So I'm gonna use this red marker. So 25 years in the industry. That, you know, that's a long amount of time. So I've started as, you know, systems administrator, software engineer. Currently, I'm AWS subject matter expert. And that's, one of the reasons for being selected for this course. Um, we're going to learn lots of AWS. AWS stands for Amazon Web Services, and we're going to look at that. So I'll bring in lots of perspective from the industry. So you'll see lots of examples I will share. I'm specifically in the financial industry, the banking. So banking's they print their own money, so it's good to work for them. They never run out of money. So quick jokes. And I also work as an assistant professor on the side. So at lots of colleges I'm linked with. My undergraduate is in computer science, master's in information architecture, and I have a doctorate I'm working on in cybersecurity. It's a little personal things. I'm married with 3 kids, wonderful one, they're pride and joy, 2 boys and a girl. I love health and fitness, so Planet Fitness, I'm hanging around there all the time. A little fun trivia about me, Clash Royale, not Clash of Clan, but Clash Royale. I run that clan. I got 7,000 ratings. So anybody's still plays that, very addictive game. It's almost like chess, but it's interactive. Anybody interested, you can join my clan if you want. All right, my areas of expertise in the field. Lots of comments on that. Right? Area of expertise, of course, cloud architecting. I handle lots of cybersecurity. So for banking environment that I'm working for as a consultant and other roles that I have, my role is typically deploying applications in cloud-related environments such as AWS and securing or certifying that the application is secure. So in the financial industry, more than anything, right, because there's lots of reasons folks want to hack into that system, I make sure things are secure. So it's a pretty important, area that I pursue in the industry. Lots of background in network engineering. In this course, you're going to see lots of network related topics. So I'll cover those. Again, subject matter expertise in AWS, we'll talk about that. I do some software development, specifically in Python, so I'm Pythonista certification. And then I do some microservices. We'll talk about that in later sections of our course. Your course is going to be focused on AWS Cloud Practitioner foundational course. So that's our goal. After learning these topics, there's an official test that you take from Amazon Web Services. They'll guide you through on taking this exam. So it's an official exam, it's a timed exam. There's a series of questions and answers you have to give and pass or fail, and hopefully you'll pass after taking our course. But our goal is to guide you through this topic. Any questions so far? So that's our primary goal, to help you understand what is involved in this, what are some of the areas we're going to cover. There's going to be lots of topics. You have already have a series of topics we're going to address. They're all designed to handle the core understanding of this level of specialization in the industry. Practitioner is certainly, it's a great start. So I'm looking at your live chat. If there's any specific question, you can just put it right there. So why me? Why am I being selected? I have special interest in AWS because the last 5 to 6 years, I've certified to the max. So I'm going to share this. Let me put that in here. Let me share this URL. I'll put that in our live chat. So everybody go to this URL. Here we go. Everybody should have that URL. Let's go to that URL. I'm going to bring it up here. So this is the AWS certification page. Lots of useful information there. Why choose this area? Let me make this a little bigger. Is that good for everybody? I don't want to make it too big, then I don't have a screen size. But you can adjust your Zoom screens as needed. I got lots of screens staring at me, and there are several questions. Can you please explain the difference between cloud practitioner and solutions architect? That's good. Okay, so we'll address that question. So let's there's, nowadays we're in the information age. So there's lots of information everywhere and anywhere. There's YouTube channels, there's plenty of video coverages of these topics, lots of other places you can learn and continue to learn. Our goal is going to be primarily focused on key elements, key topics that we're going to address, and give you a guided tour of how you want to pursue this area. So in this page, if you scroll down, you'll see these are the primary AWS certifications that are common in the industry that folks pursue to specialize in this area. And ours is, just like I mentioned, let me see if this pen works. Yeah. So here's our cloud practice. So this is foundational, knowledge-based certification for foundational understanding of the cloud. So that's what we're going to do. Somebody asked, what's the difference between this one and that one? Right, that was a question that was asked earlier. So these are, as you'll see, the further you go down here, the more advanced they become until you're at the professional level. So it takes time. Nobody's born with this knowledge, of course. You learn. You continue to learn and understand and work. There are over 200 plus services that run in AWS, and specializing in all of them is very complex and so forth. So today's topic, we're gonna dive into what is involved in some of these. So your goal is to get this, and then, the industry will have these are pretty sought after skills. So if you get this one, then you can perhaps pursue the more advanced ones and so forth. Me being in the industry and me being pretty crazy, that I just like to pursue everything to the max. So I got involved all of them, all of the advanced ones. So the professional, the DevOps engineer, and teaching ones also. This is supposed to be DevOps engineer. I put the wrong one there. So I've had this from experience. So as you're moving into your careers, these are the ones I carry. So to understand these, of course, you got to understand everything else. So I just go right to the top and certified in them. And I worked in the field this long and been pursuing this for a long time. So I was fortunate to get those. But yours is to focus in on cloud practitioner, because that's the stepping stone to everything we're gonna cover in this curriculum. We're gonna build the background for it. You gotta have some understanding of some networking, Linux, some SQL topics and others. So we're gonna dive into those areas. Clear the screen. Any questions or comments about what we're gonna cover? Why am I presenting them to you? and before we dive into the actual topics. So is solutions architect the highest? Let me make this a little bigger. So if you come down here, yeah, these two. The solutions architect and dev pro engineer, these are the most advanced. Usually it's recommended that you have several years of experience in the field to get that. This was 75 questions, 2.5-hour exam. It's almost like a board exam, or you're becoming a medical doctor or something, or attorney bar exam. It's very complex scenarios. I practiced for many years and I was successful in completing that. And this is for folks who are more into software development and automation. So I've studied that for many years and I was able to get that too. So those are the highest level. So this is foundational. These are more advanced versions of the foundation. These are specialty, and these are the professional ones. Is that clear? Any other questions? There was a question, is CompTIA A+ needed after the program? CompTIA A+, CompTIA is another certifying company. It's always good to have additional credentials. There's lots of them. So you can have A+, you can have Network Plus, Security Plus, many other. But our focus, we only learn so many things, and you'll see even just this one, the complexity and all the knowledge base needed to succeed can take some time. So we're going to focus on the cloud one. All right. Are there any other questions? We got plenty of TAs. They can alert me to address those. But I'm going to move on to our topic at hand. So these two are more for, like, I'm vetted to teach this curriculum in various formats, both in colleges and at professional settings. Yeah, more market value you hold, and more opportunities, and it's just a way for employers. You can put on your resume that you know this, you know that, just like a college degree or a certification validates that you've been properly vetted and you understand the concepts and so forth. So that's the idea behind the certifications, and it's industry just relies on it because there's so many technology changes are happening all the time. That's always been the case for as long as I can remember. All right, let's go to our topics. So this is our Codio interface. It's new for me also, so I'm gonna bring this up.
Sorry to interrupt you here, Bill, but just so everyone knows too, this is what you access on the training site. So you might want to, maybe Bill, we can give them a minute to just make sure everyone is on it and they go through it with you, because there will be some knowledge checks that you all will answer. So maybe take the next minute just to make sure you're on the training site, and under Friday, July 21st, go ahead and open this up. Okay.
Thank you, Kat. So so the way you get to it, I usually there's my
they have a completely different view, Bill, than you do.
Okay, all right.
Have a different access. Thanks.
So there's I just got a URL, so I'm logged in. So make sure you just log in and bring to this screen, and then once you're there, you'll need to get to this interface.
Yeah. For them on the training site, I'll get them there, and I'll drop the training site link again for everyone in case you're not on it, just to make sure. And then if you're having issues, I'm sure any of the TAs are going to be happy to help there. All right, just drop it in there. Okay, It looks like a lot of people are on already. So given this, I think we can turn it back to you, Bill. Thanks.
Thanks. Yeah, thanks. So, folks, here's our remaining coverage for today, and that's going to be our theme throughout. So we're looking at this program. We've carefully curated specific topics that cover the cloud practitioner certs, and we're basing it on this curriculum, the cloud support curriculum that we're covering. Each class, we're going to have a series of topics. You can see 1, 2, 3, 4, 5, 6, 8, 9, 10. There's like 10 topics for today. And each topic, it's going to progressively get more difficult as you progress in the sections. So some days like today you might say, oh, this is basic stuff. I already know these topics. That's great. That's great. You can participate in our discussions that we have going. You can ask questions, ask more details. There's going to be some, challenges. I've been in the field that many years, and I carry the most advanced certifications in AWS. And still, there's some topics that I can brush up on myself, and they're embedded in our curriculum. So everybody's going to learn lots of things. Everybody has a different pace. Our objective is pretty clear. We're just going to give you pretty guided tour, take our time, make sure everything is covered to the maximum level so that everybody understands every single topic. There are knowledge checks built into this. Like if I go here, you can see there's a knowledge check. So the suggestion is you stay with me each time we go over some of these topics. These are not graded, but we're recommending you complete them so that we can validate that you've read these sections, you understood these topics. And then at the end, you say submit to confirm that you completed those. So when I go through these topics, I will give you, we will reflect each topic, we'll give examples of each topic, we'll walk you through it. And when the knowledge check comes, we're gonna all jump in and complete our sections of the knowledge check during the live session, and give you even hints on what we covered and so forth. So everybody should be able to follow along and complete the sections so that we can move on to the next levels. But, everything in computer science or IT related topics or anything in general, builds the previous knowledge is needed to learn more advanced topics. So that's going to be true here. So you want to really understand every single topic to the best level so that you have a better understanding of the more advanced topics, and you don't want to fall behind. And given all the support we have plenty of TAs helping you. I'm here. We have the Slack channel. You can always reach out to me and we can discuss things further. We're just going to make sure you're following along, and you let us know if there's anything you need additional. I'm going to cite lots of examples and so forth. Knowledge check is like validation that you've learned it and you want to answer to the best of your ability and submit it. It's not officially graded activity, but it's like a check mark that we want to make sure that you're completing as needed. All right, so let's look at our first topic, which is introduction to IT. And here, our goal is we're going to understand what is basics of data and cloud computing. So why cloud? Again, folks, I like to engage everybody with lots of questions and feedback. So make sure your live channel is open. I have mine open. Anytime there's a question, you just put it on there. I'll glance at it and answer those. And then when I'm asking, of course, you chime in and do things. Yeah. So Louise asked why cloud. So we're going to address all those questions and look at that. So first thing we're going to look at is, the big data, and then cloud computing, and then Amazon Web Services, this AWS. What is it? Why do we need it? Why are we learning it? Why are we investing it? Why, I'm preaching it like it's, it's the best thing since sliced bread, right? It just has so many features that the industry needs. And some of the topics we're going to address, this is an intro slide. We're going to look at the data and then big data, why we need those concepts. So we'll look at the idea of what is big data and why companies need it. And then starting from here, we're going to start looking at cloud, data centers, in-house versus co-location. There's your knowledge check coming. And then different types of cloud computing models, who's responsible in each, and some career opportunities. So those are some of the areas we're going to focus on. But let's first look at the idea of big data. Right, big data. So I'm going to bring up my power whiteboard here. So the big data idea is, traditionally we had PCs and servers. And many organizations, business organizations, personal and others, were producing this thing called data. Right? That's information. Target, retail place wants to know what inventory they have, how many customers are coming in, how much they're selling, which items are selling more than others, and so forth. Right? Amazon sells lots of stuff, and we have lots of data. Every company has some good or service that they're selling. That's data. Right? So we are always interested in analyzing our data, and data analytics is a very hot topic. In the recent years, instead of just data, we've started coming up with an idea of big data. All right, here's your first question for you to jump in. And then give us your honest feedback. We all have Google and other things, access to it. We're looking for layman's explanation. What's the difference between data and big data? What do you think the word big means in lots of data? So originally we were just handling some smaller amounts of it. Now the information can come in huge amounts of size. In the computer terms, what's a size? What's typically massive amount? What's a massive amount of data in computers? We got lots of folks. Wow, there's TBs, gigs, petabytes. Excellent. Wow, you folks know your data, right? Yeah, so TB, terabytes, TERABYT. That's one type. There's somebody also mentioned that peta. Hexa. So these are all sizes. You might have heard of gigs, megs, and so forth. So these are more larger amounts of data. So big data, one characteristic it has is large amount. In fact, our slide doesn't cover it. I'm going to give you a little more than what's there, right? Our slides say, it's large amounts of data. There's a large amount, and it's broken down to for lots of different purposes. And we're doing these data analytics on it to get some information. E-commerce companies selling different types of things. Another company might be streaming services like YouTube, how many folks are watching a certain channel or other things. These are all examples of big data. So I'm going a little beyond our data because data is very important. The big data has several characteristics that we're going to look at. It's going to have 3 V's. 3 V's of big data. One is we already covered, volume. V-O-L-U-M-E. So that's 1 V. Big data has several characteristics we want to make sure we understand. The next one is called velocity. So velocity is the speed. How fast is it coming? So, if you're running some server, that's why cloud technologies are so popular. Sometimes the speed of the data that's coming to you, can your computer handle it? Right? Can you handle all the speed that the computer is sending the data on? And that's, so we might need large computers, small computers, or series of computers. So the velocity is the next thing that's commonly seen in big data. This could be a real time or near real time, and you want to drive some analytics out of it. We're always want to look at trends. You might even have services like sensor-based devices that are sending data from the atmosphere or from your environment, like temperature and others. You might be streaming things on YouTube or some other video platform, and you want to track all of that information. It's coming very fast. So that's another characteristic. Third one of the V that is there is variety. That's another characteristic of big data. We got good examples going on. Okay, great. So variety meaning data can vary. It could be in one format, it could be in another format, it could be text, image, video, it could be in a database format, and many others. So those are some of the big 3 V's of big data. In the recent years, we've actually added a few more V's to this as technology is evolving. I'm just going to reference those. One is called veracity. That's one other value. And then the final V that's showing up nowadays is the value. So there's about 5 V's. Veracity is the quality of your data. It might not be reliable, might not be accurate, might not be trustworthy. Right? Those are some of the another feature of this. And then ultimately we want to get, we want to analyze this. We want to analyze that to, for decision making. So lots of things about big data, right? So big data, we had little data first, they were short amounts. Now we can from a single source. Like if you go to a retail store, right? We can put in these small sensors on the floor, on the aisles where merchandise is located. We can track how many customers are coming in, what are they grabbing, what are they selling. We can check how many folks walk through that area, how many folks are present within that distance, what items are being picked up, what items are being returned. That all of that is very easy to collect for us. So big data and even the little data, it's all around us, is being collected at lots of places. You can have even video surveillance systems that are giving you real-time data. You can have, for instance, a billboard with sensors in it, and it's checking to see if you are looking at that billboard or not, and how many folks are walking by that billboard and stuff. So we can collect data from lots of places. So keep these in mind: volume, velocity, variety, and value and veracity. Oh, variety and veracity. So those are some of the areas we want to address. So I gave you a little extra on the big data, but for our curriculum, the main thing you want to understand is data is very important to organizations, and we want to grab as much as we can and analyze it as needed. And we want to do these real-time analytics. We want to parse through it. We want to look through it all the time and be able to interpret and come up with conclusions that we can interpret and make real-time decisions on how the data is being used. And examples of this e-commerce company is tracking that data, like medical records. So you can have large amounts of data on a certain factors from different folks, and make decisions on what trends are showing up. A streaming service can analyze and view this and look at the future content of their audience and other areas. Any questions on data and big data that we are constantly dealing with in our productions and social and other lives nowadays? Yeah, lots of good examples being shared. So let's go next. Next thing that comes up is my pen. Next thing that comes up is cloud computing. Let me make this a little bigger. So what is cloud computing then? Right, this is the main bread and butter for this course that we want to really focus here and understand why do we need it. So the idea of cloud computing is you can have a server or a PC that has its own CPU, RAM, and other settings defined on it, and you can purchase that and do what we need to do and run and start analyzing our data or do whatever we want to do with our data. And this is in your physical space. So let me bring up cloud computing a little more. So let's bring up some clean area. So let's address cloud computing. So typically what we're going to see is this. I'm going to give you a high level view of this, and then we're going to dive into individual components of this. So data centers. What's a data center? Anybody ever seen a data center? Have heard about it? Have you worked in it? What are they? Data centers. Never heard of it. Okay, server buildings, big building typically consisting of large servers, server rooms. Lots of good information there. Server. So we're talking about servers and other things. So data centers, there was a trend in the 80s, 90s, and onward. Any company that had technology needs, they would take something like a router, and we're going to talk about these devices, and switches. And these devices connected everybody to everybody. And they would purchase servers, databases, application server, member servers, other things. You might even have client machines here. And everything was connected this way. And this was a physical location. It was just some physical location that you purchased. It was your building and you defined this data center. So any data that was coming in or whatever your business was involved in, you managed it to this physical location. Data, where is data stored? It's typically stored on the hard drive of a server. It could be stored in other places. We'll talk about those. Data centers, I thought, were a big building with cubicles and people answering phones. Yeah, you might have folks sitting in the cubicles on the side, but it had like series of computing devices, and that was your own physical place. So when, let's say you're running a banking operation, right? And you purchase these machines, these high-end server. So let's say this is a Dell high-end server. You purchase a Dell high-end server. What's a typical price range for modern cutting-edge server? Anybody can get us that quick? What's the average price range for a high-end server? 10K, 5K, 3315, 10 to 20K is pretty common, right? So let's say this company needed 50 of them. That's a significant cost. And once you purchase, let's say you purchase this server for 20K, you're pretty much stuck with it. But if the company is using it or not, you're stuck with it. So that's the physical on-prem environment. The cloud let's call it AWS for now, is we purchase this server for 20K. Let's say the server is 20K, but we're realizing that we over purchased, right? We realize only 9 a.m. to 10 a.m. we're utilizing it to max capacity. And then from 5 p.m. to 6 p.m., we're using it to maximum capacity. Rest of the time, we are not really using it, and we're very limited usage is happening. So this model, the non-cloud compute model, you purchase it, it's a fixed cost, you're stuck with it. In this one, you purchase it, and you can purchase it at just these time slots for the value of 20K. Rest of the times, you can turn it into a free version or a very low cost version. So you can rent it pretty much and use it when you need it on demand. And then when you don't need it, you let it go. You just turn to a pretty cheap cost. So there's some flexibility, right? So what's the advantage of that? What's the advantage for companies from having their on-premise data centers to go into this cloud environment that AWS provides and a few other companies provide? Cheaper. That's one thing you're seeing, right? It's cheaper. You don't have to commit upfront. It's like buying versus you're renting just what you need and you're not stuck with it. Let's say you realize you don't really need 20K, you actually need 10K server. Here you purchase it from Dell, after a month or so, there's no return, you're stuck with it, right? There's nothing you can do. This one, you can make it, scale it up or scale it down. So there's scalability. So you'll see lots of benefits of this kind of environment. That's the idea of cloud computing. If you have a server that's running and not utilized, that's inefficient, right? So we said that there's inefficiency. We can, in the cloud, we can utilize and pool them as needed, and they're on demand. What is a server? Server is a high-end computer, just like a computer you might have at home, laptop, but it's dedicated to having more computing power and RAM and other services. There's no maintenance needed. That's good too, cheaper, easier. So you're going to see lots of benefits. So we're going to see here cloud computing business models and responsibilities, and especially here in AWS, we're going to see all of the benefits listed. So keep that in mind. This was just initial reference to it. Now, cloud computing is also based on capital expense versus operational expense. Right? Capital is just like that 20K. Right? That 20K we had to, company has to purchase it. That's capital. They have to invest that. Operational expense is almost like, so the capital expenses, remember the knowledge check folks coming up. So keep these concepts in your head, write a note down or somewhere, or just be able to refer back to this. When the knowledge check comes, you want to be able to answer that. So have a good reference of what big data is that I addressed, and then understand what cloud computing is, so you can provide a good explanation in the knowledge checks. So everything I'm presenting, we're just going to ask you to regurgitate it, so to speak, so that you understood some of the core concepts. So capital expense, or CapEx, we call, is based on the idea is we're basing it on the actual hardware that you have. This could be a server, firewall, workstation, whatever physical device. That's the cap expense. The OPEX, operational expense, is like rent, subscription, or cloud service. So it's like purchasing versus renting, and then being flexible enough to utilize these services as needed. So there you have it. So cloud computing, over my career, I've managed many data centers. And I think 15 years ago, I was in a data center and I spun a server in the cloud, and whatever our data center servers were doing, I was able to do it in the cloud. And I said, this is amazing. And whenever I look at technology, I like to become the expert in that area, certify and become teacher and use it in the industry. So for 15 years, I've been specializing in most of the AWS type of stuff. So, and that all started from me being in a data center and me working with servers and how valuable they are. And now we can have servers that never go down. We use them when we need them. They can go as large or small as we need to, and analyze our data as they're designed to do, and many other things. What about the data security and safety when it comes to renting space? What if something happens and the provider loses all? Mohammed, that's an excellent point. The idea of, we'll address that. The service provider gives you service level agreement. So if you purchase your server from AWS versus somewhere else, you'll get this guarantee that it wouldn't go down, or they'll give you some service level agreement. And just to give you a little view of this, before today's session ends, right? I'm going to do this, right? Just so that you have understanding of it. What we're going to do is I'm going to create an AWS server. So again, server is just high-end computer. Think about it. Alfredo is asking, can I do knowledge check on my own, or do I do it in class? Because I'm still understanding something. It's easier to do it in class. We'll guide you through it. If there's a TA has an accurate answer, we're expecting that once this coverage happens, they're actually due on the Sunday of each week. So officially they're due on Sunday, so you can do it, but I highly recommend you do it now. And any questions you have, we'll address them for you. Is that clear? So the knowledge checks that each week, they're due by the Sunday of the following week when we cover them. So each week we'll just use that as a benchmark. But you can do them. They're not super. We're not really looking for super accuracy. They're just a check mark that you did it. Okay. All right. So in today's class, just to see the value of the server, what I'm going to do is spin a server right in AWS, right in front of you, and you'll be able to connect to it and test to see if it's there without using any hardware or anything on my computer or anywhere else. So to get the big picture of why we do it. If we had to do this on premise, we would have to buy the server. I would have to set up my network there. I would have to buy equipment. I would have to set up an internet connection and so on. So instant ability to spin a server. So we'll reserve that time for that. We're almost reaching our first hour, and on the hour we'll take a little break, and then we'll move forward next. Let me clear this. So let's go next. So data centers. What are data centers? Right? Just like I mentioned already, they are dedicated physical space. So let's go back. So data centers, try orange, dedicated space where you're hosting your information. They have their own large computes, rows of them, and you're processing your information there. And this is traditional. That's what happened in the industry. So this trend started happening, and I've been in the industry a long time, so I saw that 15 years ago there was a little trend, and then nowadays everybody is building these data centers. So so this trend has been moving that way. So if you were a company in social media, international payment, large scale company, you had your own data center, physical one. But the disadvantage was large initial investment. And as technology changed, you had to change with it, and there was additional costs, pretty expensive to do that. You had to have staff that needed to secure it and maintain it, and all the costs associated with that. So that was a challenge. The other downside was, how would you secure it? And somebody mentioned it here. Security was a big issue, right? In the financial industry, I do lots of PCI standard. We also use HIPAA standard. There's one called CIS and a few others. It's easier to get a data center that is already certified for the security instead of you doing it yourself. So that's the idea. And then other things like physical premises, temperature, physical hardware, and all these things, you have to maintain that environment. What is HIPAA standard? That's very common standard where we have to make sure privacy of your data is there. The exact acronym you can look it up, but the idea is the information that you have in this standard is protected, and there are lots of compliance related things, and it's for medical records. And technically it actually evolved from other sources, but medical is common reference to it. All right, the link on your curriculum, I'm in that, and you can see there's your data centers. You see there's your server. This person walking on, that's a typical data center. This is from Cisco.com. Lots of servers and so forth. There are different goals of the data center. There's some references being given. There's a network there, storage and compute. And we're using devices like routers, switches, storage systems, and servers. Each of these has a link. Yeah, so each of these you can explore from Cisco's perspective, what each of those do. So, so data centers, the idea of data centers is it's your own dedicated data center. You have your series of devices here, and they're all connected, and you're managing your company using this physical location. The cloud version is going to be, we're not going to build it ourselves, the physical part, but we're going to rent sections of it from a cloud provider. So that's data centers. Now, clear. We're on top of the hour. Right? Let's do how many minute break should we do?
Let's do a 10-minute break.
10 minutes.
Yeah.
Can somebody can you put a timer, and I'll stop sharing.
I can get one going for you in just a second.
Okay, thanks.
Right now.
So let's do a 10-minute break, do some stretch ups. I'm gonna do some push-ups and stuff. So occasionally you might see me doing karate moves. I'm testing for my black belt tests in the next year, so I usually practice those.
All right, here we go.
Great. All right, we'll see you folks in 10 minutes. That's right on top of the hour. Whichever time zone you're in, 10 minutes past the hour, we'll see you. Okay, folks, welcome back. Let me share my screen again. There was a question from Stephen. Have I ever built a physical server at the data center? And I'm kind of geek, love physical hardware. There are certain certs or anything like that down the road I can get to not just the software side. Yeah, Stephen, that's a great question. So Stephen's question is, have I dealt with hardware in the data centers? And is there a specialization you can do in that? The trend, unfortunately, is on the software side. Physical, servers were, that was a pretty sought after skill, physical servers and being able to maintain it. So I built them from scratch. We would add more memory, processing, modify motherboards. And when the hardware failed, how we would resolve those issues. Pretty sought after skill. Servers are still, physical ones are still around. They're gonna be around probably most of our lifetime. But I see a trend in the other direction. And there was Amazon's product manager, Warner Vogel. Don't ask me how to spell it, but he mentioned it. There's a famous quote: "Everything fails all the time." Right, and he was one of the server person. And what he relayed was his point was that whenever companies have high-end computers called servers that are servicing companies' data, eventually they're gonna fail. Everything man-made or hardware-based is gonna fail. And when it does fail, major problems for the company. So the idea is the hardware failure. How do you overcome that? In the cloud computing model that we're going to look at, nothing will fail, right? What I'm going to do is I'm going to spin out a server. So before this session is over, I'm going to demonstrate that. So what I'm going to do is I'm going to spin a server in AWS. That's going to give us, that's going to be almost, I think, few cents a minute, an hour, 99.99 service level agreement per year. So, so if I spin this server out in AWS cloud, by default, that's the service level agreement you get. That's, if you do the math behind that, that's 52 minutes of downtime per year. So if I buy a server from Dell, 20K, I plug it into my data center and I, make sure everything's on. How do I make sure nobody steals it? So I have to have proper security. Nobody tampers with it, so I have to have cyber-related security. Nobody, unplugs it, power, redundancy, and on and on and on, and then hardware failure. What Amazon does, or most of the cloud providers do, is they have a software that's checking the health of these servers. And if the hardware is failing, it can move you into a different instance of that server behind the scene. And they give you 52 minutes of downtime per year. And what I can do is I can put in 2 of these and create what's called ELB, Elastic Load Balancer. It's another software that checks to see if this is healthy or not. So now 99.99 and 99.99, right? 2 of them. And what's the likelihood of both of them failing is almost negligible or 0. So now I can have my company data, whatever I'm serving, like my website or anything I'm serving at 1 second of downtime per year. Very easily to do all of that. I can demo it in this class. Even we'll demo this, and maybe later section I'll show you this part. So without investing heavily, without creating purchases, the resiliency is so powerful in the cloud that's it's no brainer. Every company is shifting toward it, and that's why learning cloud is so important. That was all to answer Stephen's question. Stephen, so that your question was, is hardware still viable and it's good to learn? Of course, there's still some demand, but you can see with this virtual cloud-based servers, you're not spending much to innovate and try things out, and you don't have any hardware failures. So why have hardware when you don't have to have it, and failure that can happen? Did that answer your question? Oh, great. Anything else we missed? So you can bring it up again in the chat scroll, and I can address it. All right, we're going to keep our time right in. We're going to end exactly in time. So the next hour also we'll do another 10-minute break, and then we'll have 30 minutes. So I'm going to end exactly on time. And so we're, as you can tell, we're halfway through our coverage here. We got these topics left. So we'll tackle those in the next section. But so far we looked at, and your knowledge checks are coming up. So get ready for those, and we'll let you work through those. Again, they're just non-graded, but they're used as check marks, as benchmarks to see if you understood the key concepts of the topics that we covered. And then, so, try to get them done, but officially they're due. And then at the end, you want to submit. And then the deadline for this is Sunday cutoffs for that week. All right. So when we have our in-house or co-location. So in-house, just like the name implies, is you are a bank, a hospital, government entity, and you have in-house data center. That means you're managing the physical in your organization itself. So within the bank, you'll have this data center that you were managing. And that was common theme. So there were two types of data centers, either in-house or co-location. So in-house is, your organization is designed so that you want to, ultimately it's all about the data. The data is the most critical part. So whatever your compute environment is handling, you wanted to keep all of that on your physical premise. And that's the in-house data center. The co-location part is a third part. So you're a small business and you want to host some site. So you're looking to downgrade your space, clear it up from any servers, and you want to rent a space from another company to do this service for us. So that's co-location. So there's another company that's playing the middle person role of handling your data. All right. Okay. Well, I misunderstood. I did the knowledge check. Okay, good. Let's hear this. Let's go to the next slide. There's your knowledge check. First one, Let's all hone in on this section and complete this knowledge check. First one is, what is big data? What's the significance of big data? You saw me spend 10, 15 minutes explaining. We just want to put your answers there and then submit.
And then also, sorry, Bill, to interrupt here. I just
Sure.
want to make sure that I address any questions that might come in regarding the knowledge checks. So we'll do one by one. We'll take some time to do these knowledge checks right now. Once you're done with it, you can click submit answer. At the very end, we'll show you how to mark as complete. Now, please note, just because you submit your answer, you still have the ability to modify your answer. Okay. But I think it's just a good practice, given what you've learned thus far about these questions, to kind of just jot down what you know. So again, we'll take some time. I know Bill's going to give you all some time to work through these questions right now. So have no fear, we can get them done today. Thank you, Bill.
All right, thanks. Thanks for that. So I'll just read each one, give you some pointers, some hints, refresh your memory, and then you can jot them down. And we'll give everybody 3 minutes or so. It's good. All right. So first one, big data. Just anything you remember. I said many things. The value of it. You can, the idea is, what is the purpose of it? How do businesses use it? And we've mentioned many things and cited examples of that. Then cloud computing. How does it differ from traditional on-premise hosting? Right? What's the value? What's the point of cloud? Why shouldn't you do it all on a traditional on-premise? What value do you get from the cloud computing model? And then finally, this was right in your curriculum, the capital expense versus the operational expense. Let's explain the shift from capital to operational that occurs when the adoption of cloud technology. So let's put a few lines, and then, and as Catherine mentioned, you'll get the option to edit it later. But you want to jot down some things, and so we can move into the next section. Yeah, good suggestion. Use your own terms, provide layman's explanations so that non-technical, and put in your own words. Knowledge checks are in your curriculum. So if you click on your curriculum right here, I'll go to your Codio. And then if you click on this section here, you should see knowledge check, or you can scroll through and you should see that. I think slide 6. All right, so let's that should be 3 minutes. Let's go into, you can finish up anything you have there, and then our next topic we will look at is cloud computing models. If you need to edit anything later, that's fine. All right, so I'm going to start the discussion of the next section, which is different cloud computing models. So first one we highlight in this section is called infrastructure as a service. So let's address these. Infrastructure as a service, IaaS. Right? The idea behind that is the organization is purchasing its own compute, storage, and networking resources on a pay-as-you-go model. And your team has enough IT savviness to design your own environment without having the physical hardware. So in this model, right, I'm gonna bring up. In this model, under this model, oh, let's bring up. Oh, the cloud we're gonna use is primarily the AWS, but there are others, keep that in mind, but our focus will be that. So in this model, infrastructure as a service. What we're doing is we're defining the network environment. We're defining the actual servers we're going to put in. And we're creating our infrastructure to, let's say there's an application that you have running, you want to service that. We can have internet circuit. So the entire infrastructure, what kind of servers you want, what kind of databases you might need, what kind of network you're going to put in, what kind of traffic you're going to open up. That's all you're doing it, and you choose that model based on your need. So that's the first one. So the client responsibility is deploy, maintain, support application, and the cloud provider is maintaining the physical. So what, you'll just spin a server, but the actual server guarantee, the hardware, the power, the compute, the provider would handle it for you and give you service level agreement. So instead of your IT provisioning the physical server, setting it up, the provider of the cloud service will handle that for us. Let's look at this video together. So that's the first model.
Well, you may have to share your sound, Bill.
Oh, well, let me try stop sharing, share sound.
What is cloud computing? Cloud computing is a paradigm that allows on-demand network access to shared computing resources, a model for managing and processing data online via the internet. Some cloud computing characteristics include on-demand service, you use it when you need it, network access.
Yeah.
Yeah, it was good before. Thank you.
Oh, it was something I couldn't hear. Yeah.
3 delivery models of Cloud computing basics. The advancement of technology encompassing
folks hear it,
networks,
right?
storage, and processing power led to epitome of computing. In this
Oh.
century, it's called cloud computing.
Hey Bill, yeah, we can't see the video. We only see your Slack screen.
Oh, let me see, make sure. Hold on. Stop sharing. Oh, the wrong one, sorry. Share. Screen 2. First sound. All right. How's that?
Yes, we can see it now. YouTube.
And you can hear it also, right?
Or
Yeah.
commonly referred to as cloud.
How come I don't hear it?
What is cloud
Maybe I don't
computing?
need to hear it.
Cloud computing is a
See what
paradigm
time
that
is it?
allows on-demand network access to shared computing resources, a model for managing, storing, and processing data online via the internet. Some cloud computing characteristics include on-demand service, you use it when you need it. Network access, using internet as a medium. Shared resources. Resources are pulled together and used by multiple clients. Scalability allows elasticity of resources. 3 delivery models of cloud computing: SaaS, PaaS, and IaaS. Cloud
There's your 3 model. Infrastructure as a service, platform as a service, and software as a service. So remember, just have general knowledge of each from this video and my discussion. Knowledge check, one more coming up, so pay attention.
Cloud computing offers different services based on 3 delivery models. When arranged in a pyramid form, they follow the order of SaaS, PaaS, and IaaS. What is SaaS? SaaS, or software as a service. It is a service that offers on-demand pay-per-use of application software to users. Unlike licensed bought programs, this service is platform independent, and you don't need to install the software on your.
So the advantage of this one, as you can see, is you have some software you just want to run. You don't care about anything, it could be Microsoft Office 365, some application. And you don't want to be worried about or manage or have the need to install things and do it. You just want to run the software. This could be your model.
PC. The cloud runs a single instance of the software and makes it available for multiple end users.
Yeah, Gmail
This
could
makes
be
cloud computing cheap. All the computing resources responsible for delivering SaaS are entirely managed by the vendor. This service is accessible via a web browser or lightweight client applications. Who uses SaaS? End customers are frequent users of SaaS. Example products and services of SaaS.
Any of
Popular
these
SaaS providers
applications,
offer the
popular
following products
SaaS
and services.
providers.
The Google
So
ecosystem.
SaaS is very common in the industry. So you're just running it from the provider and you don't have to worry about it. You just want to use the software.
Systems such as Gmail, Google Docs, and Google Drive,
Google Docs,
Microsoft Office 365, HR and help desk
Salesforce,
solutions,
all these are
and
common
customer relationship
SaaS.
management services such as Salesforce.
Software as a service.
Pros. Universally accessible from any platform. No need to commute. You can work from any place. Excellent for collaborative working. Vendor provides modest software tools. Allows for multi-tenancy. Cons. Portability and browser issues. Internet performance may dictate overall performance. Compliance restrictions. What is PaaS? PaaS, or Platform as a
that's
Service.
SaaS. Pretty straightforward, right? You have some application, you got to run somewhere, right? And it's running by the provider's infrastructure, and you as the consumer is just using the application as needed. The next, and you'll see, the further we go down the tier, the more control that we will have. Ultimately, infrastructure as a service is where we would define our servers, our network, and how the application is going to run on top of that, or whatever else we want to run. But the one in between is called the platform as a service. So let's look at that.
Service. This service is mainly a development environment and is made up of a programming language execution environment, an operating system.
There was a question, I couldn't get the disadvantages of software as a service. It's you don't have the underlying control of the infrastructure. So it's just, it's software, and usually cost will be more because the provider is handling for you. But that's the software as a service. So you don't have the control of your environment where the things are running.
A web server, and a database. All of this encapsulate the environment where users can build, compile, and run their programs without
this is the
worrying of
next
the
one, and
underlying
we're gonna
infrastructure. In this model, you manage
the
data and the
service from
application
Amazon
resources.
called
All
the
other resources are
Amazon,
managed by the vendor.
Beanstalk.
Who uses PaaS?
Right, Beanstalk is going to be the example we're going to show you from Amazon. What it does is, let's say you design some application that is a game, right? It runs some stuff, but it runs in a browser, right? So you could create your own servers on premise, create the network, other components and other things. That's the on-premise one. You can create it in the infrastructure as a service. You can use the cloud provider, build your network in the cloud and your resources in it, and deploy it there. Or you can have it as a platform as a service. You can let the cloud provider provision your environment and manage it for you, and you just run your application on that. So that's the platform as a service.
This is a domain for developers. Example products and services of PaaS. Cloud providers have the
And they're
following as the PaaS
independent.
products
They don't
and
have to
services.
encompass one over the
Amazon
other.
Web
It's just the
Services,
provider
Elastic
model.
Beanstalk,
And we're
Google
gonna
App
check out this
Engine,
Beanstalk
Windows
shortly.
Azure
I'm
Heroku,
gonna
and
share the
Force.com.
site for that.
Pros: cost-effective, rapid development. It's scalable. Faster market for developers. Easy deployment of web applications. Private or public deployment is possible. Cons: developers are limited to providers, languages, and tools.
There's
Migration
your
issues, such as
cons.
the risk of vendor lock-in.
These are disadvantages. There are limited number of languages under the AWS model, right? Under the AWS model itself, you'll see all the popular languages are there and tools, but you're tied to the provider. And then once you're part of the platform as a service, the migration process can be complicated. All right, let's look at the final one, my favorite
What
one.
is EaaS?
Is the
EaaS, or Infrastructure as a Service. This service offers the computing architecture and infrastructure. That is, it offers all computing resources but in a virtual environment.
So all of your compute, your user access, your data, virtualization, network, you are controlling it. So this is, you got to have certain skill set to define the environment that you're going to run. So this is the most technical one and the best utilization of your resources, because you're going to craft the compute. Like, let's say you need certain type of processor, a certain amount of memory, a certain amount of storage, certain amount of this, certain amount of network settings, certain amount of ports that you need open or security that you want. You get to craft all of that on your own and then run your application on that. So the very first one, you just buy the application from the provider. In the second one, you buy the service that is pre-provisioned. It's out of the box, and the provider will manage it for you. And the third one, you provision everything yourself and then run your application as needed. Everybody's good with that explanation?
Environment so that multiple users can access them. These resources include data storage, virtualization,
that's true.
servers, and
It's like
networking.
your own
Most
phantom
vendors are
computer, virtual
responsible for
computers.
managing the above 4 resources. If you will use this service, you will be responsible for handling other resources such as applications, data, runtime, and middleware. Who uses EAS? EAS is mainly for sysadmins. Example products and services of EAS. They include Amazon EC2, GoGrid.
So this EC2, this thing, EC2, before this section is out, I'm gonna provision that just to show you if you haven't seen it. And we'll play around with that just to get the idea that it is a real server behind the scene.
And Rackspace.com. Pros: the cloud provides the infrastructure. Enhanced scalability, dynamic workloads are supported. EAS is flexible. Cons: security issues, network and service delays. Examples of companies that use cloud computing: Amazon's AWS or Amazon Web Services. When it comes to companies using cloud computing, AWS takes the lead.
So
This
Amazon
cloud
takes the
computing
lead,
company
but there are
offers
also
EAS and PaaS services to its
Microsoft
customers.
Azure, there's
It's
Google
popular
Cloud,
for its Elastic Compute Cloud, EC2, among other services such as Elastic Beanstalk, Simple Storage Service, S3, and Relational Database Service, or RDS. Apart from the complete suite of cloud computing, it offers other cloud-related services including Internet of Things, IoT, cloud security, and mobile services. iCloud. This cloud from Apple is majorly for Apple products.
iCloud
It allows you to back
we
up
all
and
used
store
it.
all your
We're backing up
multimedia
your
and other
content,
documents
that's
online.
example of
This content is then
a
seamlessly
service
integrated
that's
onto all your devices
storing your
or apps
information
in
the
case you
provided
access
cloud.
it from them. Microsoft Azure. This cloud is used and offered by Microsoft.
This is
It
a
offers EAS,
Microsoft
PaaS,
version.
and SaaS for its enterprise software and developer tools. If you have ever used Office 365 products, then you have used SaaS. Google Cloud. The Google Cloud Platform is a universal cloud for Google's vast ecosystem and also for other
Google
products such
Cloud.
as Microsoft Office. It allows collaboration, storage of data, and also other services offered by its cloud computing suite. IBM Smart Cloud, using private, public, and hybrid deployment models.
So lots of cloud providers. The biggest, the most oldest, the most complex, the most sophisticated is the Amazon Web Services. And our course revolves around that. Lots of information. Yeah, absolutely.
IBM Smart Cloud provides a full range of EAS, PaaS, and SaaS cloud computing services to businesses.
Again, this video is in your course. So, in your own time also, the more you play a few times, the better you'll get understanding. So now we can, let me clean the screen. Clear screen. So now we can just quickly reference these models. So the first one being was the infrastructure as a service for this model. So here you're in control. You make these specifications, how your environment is set up, you arrange your servers, you arrange your computing need, your storage need, you're technically savvy and you have the skills to do it yourself. And here's a further reading link. You can see this is the Amazon documentation. Amazon has plethora of information, everything I've said and more. Amazon.com and their documentation covers this stuff in lots of details. And you can see infrastructure as a service. What's the purpose of that? So the idea is compute, storage, and network resources over the internet, you're following a pay-to-go model. You don't have to do the physical setting up, powering and maintaining a data center, but it can emulate from smallest to the largest data centers ever. Right? So most companies like Dropbox or any of the media services like that you will watch from platforms, banking, lots of, Capital One is all AWS behind the scene. And infrastructure as a service is being used rather than your own data center. The next one that we have is platform as a service. So here, the Beanstalk. Let's look at the Beanstalk. When you pause and expand on the video content. Okay, thanks for that tip. That video will play separately. There's the Beanstalk. Elastic Beanstalk. So this is a link in your curriculum. This is referring to the Beanstalk as a service. Right? There's a video here that they'll show you what Beanstalk is doing. And the goal here is you take your application code, right, and you activate the Beanstalk service. There's a console. It'll ask you some questions. What type of setups do you have, and other thing, what language you want to use, and so forth. And it'll set up the Beanstalk platform. So it'll set up all your platform, which will be any EC2s, some buckets, some other CloudWise service, or any other services, and it'll deploy the application for you, and your code will run on top of it. And this is all managed for you, just like a single environment. You just say, I have this Python code or Java code or some other programming language code, and I don't have time or the skills to run whatever servers I'm going to need. If there's increased demand, I want somebody to manage it for me. It should scale up, scale down. I just want to run my code. I just want to run my code as needed. I don't care about anything else. So that's the Beanstalk process. There's a video here you can check out in your and then finally we have software as a service. We talked about that. That's like Google Drive, any of the Office products. You can run it as the application itself, and Salesforce, for example, Microsoft Office 365. You're not worrying about the underlying infrastructure. The provider is just giving you the ability to run the software, and you're not concerned with anything else. And here's a link for that. All right, let's go to our next section. Any questions on these? Anything else? So we should clarify on that. So infrastructure, more control. There's actually a chart coming up. Let's look at this and then address any questions. So here, this gives you a perspective of what we're trying to do. The blue part is company responsibility. If you are that tech savvy and you like to torture yourself sometime, and in traditional data centers, that's what we did. It was the in-house IT service, did everything. You define the network, storage, server, any virtualization technology, the operating system, any middleware, You ran your software, your data and application. You did everything, right? And that's where the traditional data center model comes from. That's the on-prem data center. And in, lots of places that still exists, but the trend is, why should you have to manage these? Because this is where lots of problems happen, right? This is where, operating system malware might happen. Your virtualization might fail. Server might power out. Storage might fail, hardware. Network is complex, routing, switching, all that stuff. So if you don't have to do all this, why do it? And it's more cost effective than infrastructure as a service comes in. You just handle your application and runtime and other settings that you can control. You define how your network is, what compute you want, what components, how they're talking to each other. So you're setting up most of this. The middleware part of it, the actual cables to run the network, the actual physical server and powering them, the actual virtualization technology, meaning, if you have certain hardware and you're going to split into 3 servers, and then what type of operating system you're going to put, Windows or Linux or something else, that you don't have to do. So that's the infrastructure. If you want to do even less, right, then you can do platform as a service. You bring your data and your application, the Beanstalk, and Beanstalk will run all of this for you. And if you just want to run your application, you just want to use it, you don't have any time or skills to manage any of this stuff, then SaaS. Right. Everybody's with me so far? Any questions, comments about these 3 models? Oh, here's your chance to give us your feedback now. When would it be good? Knowledge check. So let's complete these knowledge checks. It's 52 past the hour here. So we'll give you guys a few minutes to, we'll do 55, 56. So 4 minutes. See if you can put in here some, this is true or false, or true, and this is just a fill-in. When would be a better idea to host a server using your own IT versus renting data center server? When do you, look at this diagram, when do you want to do it yourself? When would be a good time? Good use case for that. When would be a better idea to host a server using your own IT versus renting data center space? So that's, you just want to, even from the previous slides, when we said, do you want your own IT to handle it, or you're renting the data center space from somewhere else? And then here's the SaaS, PaaS, and IaaS models. Under the IaaS model, companies are responsible for maintaining their data pipeline and software that runs their application. Is that true? Is platform as a service, the companies are responsible for maintaining the software that runs their application. And in the SaaS, is the company is only responsible for maintaining their application. And in the IT, in-house IT, a good model, if your company needs to maintain their entire tech stack by themselves and is sophisticated enough to take full responsibility for their tech stack. And final questions. SaaS is a good model if your company needs to maintain their entire tech stack by themselves and sophisticated enough to take full responsibility. Can't be both of them, right? So one or the other. So put in check for those items that are true. And one more question. Why is it important to have a distinct, explicit separation of responsibilities? Why do you think this is a good idea to have specific responsibilities listed and defined by the providers? All right, we'll give you another minute or so, and then you can we'll look at the last sections of our coverage. There's one slide here, and then the final slides on AWS, and right here, I'll spend 10 to 15 minutes to demo the AWS environment. And then what we're doing is for this one, you're just putting in which one is true. We put in the check for some of these are true and some of these are false. So whichever ones are true, you're putting a check in. All right. So you have the option to modify your answers there. You can put in whatever you remember for these and then modify as needed. Yeah, it takes time to grasp these concepts, so no worries. But you have the content and so forth. All right, so this there's a slide. Next slide is on careers. This is slide number 9 in your curriculum. Is on careers, right? Lots of career choices in this. Why should we learn? You're investing, you should be commended for attending on Friday this rigorous session that we covered for 2.5 hours or so on these complex ideas. And so what's in it for you? There's a tremendous growth it's exponentially growing. I can vouch for it. I'm coming from the industry. From the financial side, the role I play is cloud architect. So that's usually the highest level. And we are always interested in hiring folks that can help us because there's lots of problems to be solved. So cloud architect is the highest usually, cloud engineers, developers, and cloud security specialists. Those are going to be the entry level that you want to come in on. With the new machine learning and artificial intelligence, there's even more demand for these types of environments. And major players are AWS, Microsoft Azure, and Google, just like we highlight. So the goal is, you're saving the organization, you're providing lots of benefits for the organization. So and from the provider side, a lot of stakeholders are involved. Ultimately, you can see there's a tremendous value that comes from this. Traditional data centers are no longer being built, and there's minimize need for moving things in the traditional data center, and more trend is toward cloud provider because of the benefits. And we're going to see some well-architected framework in the next slide, all of the value that comes from that. People get entry-level job just with the cloud practitioner certificate? That's a good question. That's your entry point into the environment. And depending on your other skill set, your business acumen and other specializations you might have, you want to at least get that, so that you can tell your employers, look, I have this credential, I understand cloud technology, and I can help you manage your environment the best way. So once you are into the field, obviously the more you work in the field, the more marketable value you get. But just like in the beginning, I highlighted various other advanced certifications in that. Then you can, once you have the cloud practitioner, solutions architect associate is the next track. You can also do developer associate. And then after working in the field several years, you can try some of the specialties or the ones I did, for solutions architect professional and the DevOps engineer for automation. So, enjoy the journey. It's, you don't want to just go from one extreme to the other. Take your time, learn it. It's a lot of fun. There's so much happening, so much need for this. And there's just tremendous opportunity in the field. Think about, millions of companies that have data centers, and they're optimizing their cost and security and resiliency of their applications. And this is the environment they're doing it through. This is certainly your first level. Yeah, we have to start somewhere. And we want to guide you through what exactly is it. And then the first certification, the skills essential in cloud, certainly you want to do it and then move forward in that. Why is AWS better than Microsoft Azure or Google? Ramesh, it's better is, your choice, whichever choice of words you want to use. Nobody's saying one is better than the other. What I'm saying is AWS adopted the cloud technology many, many years prior to Microsoft or Google. So they have the most sophisticated environment, the most complex. So my view is usually if you understand the trend setter, which is AWS, then the others can be easier learning curve. But each company will have its own adoption model. All of this happened from the original history is Amazon originally defined their e-commerce. They were at one point a bookstore, and everybody probably heard of that. They were selling just books, and all of a sudden they were selling everything. And they were the first e-commerce company, meaning on the web, they were making money and selling stuff. So if you had in the 2000 or .com era, if you were the first company, there were lots of needs to optimize your compute environment. So they had their own data centers, and they realized it's hard to maintain. So they came out with some of this technology of setting it up into the cloud type of environment and using some of the tools that we use to this day. And that's, since they were so successful, they're selling that model for other businesses to use rather than to reinvent the wheel, so to speak, in the compute environment to set up your own infrastructure. So that's where all of this is involved. All right, we're ready for our next break. Should have a timer here, right? Bring up a timer. We'll do 10 minutes. And we'll see you guys in 10 minutes. All right, folks, see our final break, and then we'll do our last few minutes of our coverage. All right, folks, let's finish up our session. We're gonna end 5 minutes before our official end time. So any housekeeping comments and other things, we can, our team will take over. So let me share screen. All right. So we were looking at our slide number 9 here, careers. So just to recap, lots of opportunities. That's why we're learning. That's why we're here. Data is everywhere, and our ability to design IT solutions and environments that can help solve business problems within the cloud. The models we looked at, and just want to run the software, or you want to run your platform itself, and you don't want to let the cloud provider handle the infrastructure for you, or you want to do it all in the cloud, or you want to do it on your own on-premise. Those are the 4 possibilities we looked at. The cloud providers, these are the most popular one, AWS being the most popular. Ultimately, the goal of cloud operations specialists is to keep the costs managed and define the technical solution the company's looking for. And there are lots of skills that come into play, and in each of our section, we'll look at some of those, understanding different components of network. Like next, on Monday, we're going to look at Linux and start looking at some fundamentals of that right here. We're going to look at various storage needs, provisioning, critical thinking, project management, communication with technical and non-technical staff. So those are some of the popular themes you'll see that we'll be using. Scroll down my live chat, make sure any new questions. So our final slide on this, I think attributions or I guess links to what is AWS? So this is, and I promise I'm going to provision a server in front of you just to see. So this is, it encompasses series of services. So let's look at that. So here's console. So I'm just going to log into, and you'll get to do it in your sections later on once we dive into more advanced topic. So here you can see I'm logged into this. This is the console screen. And you can see if you want to work with analyzing your data, look at all these services. Looking at application, blockchain, if you want to handle your computers rather than physical ones, you want to buy them or lease them from Amazon. This is an example of that. If you want to do miniaturized version of your compute called containers, you're looking at databases, you're developing, if you want to do machine learning, internet, on and on and on. It just everything and anything that has happened in the last 25 to 30 years that I've seen in IT world is now under one umbrella or ecosystem that you can utilize to design anything that your business needs require or any other needs require. So that's Amazon Web Services. Here's a quick overview I'm going to give you. What we're going to do is I'm going to create a simple environment like this. It's going to have a network here, and I'm going to spin out a web server just to show you that how quickly and efficiently we can do it with just matter of a few clicks, and we can automate all of that. So my goal is to spin a web server in AWS. And what should we do on the web server? I'm going to host a site. Right. We'll say welcome to Bill's site, something like that, right? Why does he spin out a server? Instead of installing it, I call it spin because we're really not installing. It's just pre-provisioned version of it. So I use that term. So that's our goal. And what you folks are going to do is you're going to take your laptop you're on, and you're going to check to see if this site is active. You're going to check to see if this server really got provisioned. So here it goes. Look how straightforward or a matter of few clicks. Again, I'm behind the scene, I'm doing lots of stuff. So in these services, one of the services we have is called EC2. This is called the Elastic Compute. Right, so this is the Elastic Compute. And what I'm going to do is under instance, I'm going to create, and we'll call it test 2. I'll just call it that server. I'm going to host a site. What kind of operating system should I use to host a site? Let's see if get you folks involved. What's a good operating system just to host a site? Easiest, most cost-effective. Yeah, Linux is easiest. Monday's session is going to be all Linux. So stay tuned for that. And Ubuntu, very popular version of Linux. If you don't know what that means, and just hang in there, we'll cover all of that on Monday and get you started. So I just said I want to create a server. That's my server. So there's no physical hardware, as you can see. I'm sitting here. There's no hardware I'm using. I'm going into AWS, set up an account, and I'm going to spin a Ubuntu. Now, it's asking me what kind of processor I want. remember like when you're buying a computer or laptop, it asks you, you want, this kind of process. So here I'm gonna just test it. So I'm gonna go cheap. This is called the free tier. I'm using that. For security reason, we're gonna lock this machine. So it's gonna use a key, a private key to lock it, and a public key that will be available. So nobody else can get to it. I'm just gonna say I don't need keys yet. And then I'm gonna put it in this network that I have already defined. And this is important. I know there's a lot to explore here, but I just want a web server. Everything is locked up on that server. So we're just gonna open up. First thing is opening up is our ability to connect to it. That's called the SSH. If you happen to know this, you can chime in. If you don't, we're gonna cover it in later section. What else should I open on this server? I want a web server. So I just want to service a website. What traffic should I open? Anybody happen to recommend anything? I need a web, port 80, that's great. HTTP, right? So we'll do HTTP. And we'll say open from anywhere. Anything else looks good to open? What if I want to test to see if it's alive or not? Anybody happen to heard of any of these other ones? ICMP, somebody mentioned, excellent. So I'm gonna turn on ICMP and anywhere. So it's a Linux I'm dropping in AWS, and I'm opening up the web and ICMP, which is for testing. There's a utility called ping to see if the traffic is there. All right, I'm ready, launch. Oh, no, I needed to paste the script in there, sorry. Hold on. They're too fast, right? Do launch. I'll call it test. Test 3, Ubuntu, and then I'll just use it. So this is just a quick demo that look at the power, how quickly I can do things. So I said I want to open up, everything is locked up. I'm just opening up web traffic on this from anywhere, so you can connect to my website. And then I'm opening up this traffic called ICMP. You'll see why in a few seconds. And then what I'm going to do is, it's a Linux, so I'm going to host a site. And in Monday's lecture, we'll learn about what's called script. So I just want to show you ahead of time. So what I'm doing is right in here, I'm going to say, when this Linux machine is spun, I want to run this script. And what this script is going to do is create a website that says, welcome to Bill Biggs Correlation 1 site. That's all. Again, just pay attention what I just did. I went into AWS, went into EC2, spun a Linux as an option, gave it a name, Ubuntu, left all these options as is, and then opened up traffic for web and ICMP. I want to do not custom, I want to do all ICMP. All right, we should be ready to go. So I'm going to say launch. And there you have it. It's giving a few seconds and we should be ready. Let me go into this. And what you want to do is grab this. I'm going to paste this IP address for everybody. I'm going to go in here and paste this IP address for everybody here. This is called an IP address. And what you want to do is, first thing you want to do, if you have access to it, go into your Windows and type, open up command prompt. Command prompt. So you're just going into Windows and saying CMD, and this window called command prompt. If you have access to it, if you don't, that's okay. and then type in their ping and the IP address. And hit enter. And you should see a reply coming back. Everybody see it? Everybody see it, like it's replying back. So I just spun some server in AWS and I'm asking you, are you alive? And it's saying yes. And now I'm going to paste that IP in your browser. By pasting in your browser, you can even do Control-Shift-N incognito and paste it in there. Now look at that. So I just, that quickly, I was able to go into console, spin a server, host a site, and there's a Linux running behind it. I can do almost anything I want with that. That's how quickly it is and efficiently. Think about in the older days. Imagine this was a data center. We would have to buy cables, switches, routers, internet circuit, order from Dell or some other place, put in the server, activate it, power it, install it. That's the idea of cloud. Look how quickly it can happen, right? Aren't you amazed? All right, let me stop sharing. Oh, sorry. All right, let me finish up our discussion. I know we're very short on time. I wanted to finish 5 minutes earlier, so let's just. And then all of this I just did, we're gonna do it in our section later. I just wanted to show you ahead of time. So let's wrap up our section. So the benefits are, it's excellent performance, cost, reliability, security, and sustainability. So lots of benefits to having cloud. So you can read through some of those and you'll see that. And then the final section is just attribution. These are links to some pictures and other things. All right, that's all, folks. That's our coverage for today. Remember, tomorrow on Monday is Linux. Then we're going to dive into networking, and it's going to be, just as riveting as this one. So enjoy the session. Back to you, Dana or Catherine.
Thank you so much, Bill. All right, everyone. So hopefully you all had a really stimulating first day. I know for many, it can feel a little overwhelming, but just remember, we will post the recordings on the training site, so you'll have access to it. You all have access to these notes, at least the ones that we've gone through Codio through the course website. Now, what is due? Okay, so every Sunday at 11:59 p.m. Eastern time, you will need to have completed all the knowledge checks for that given week. For this particular week, you just have one set of knowledge checks to do, which is whatever was listed on our Codio notes today, right? So just a couple things, and I will put these in the official announcements, everything that I'm saying right now. But after you complete a knowledge check, there is a submit button. You need to click submit each time you are done with the knowledge check. If you need to modify your answer, it will show you modify answer. You'll have the ability to do so. Now, once you're done with everything, on the very last slide, in this case, slide 11, attribution slide, the very bottom, there's going to be something that says mark as complete. Now, when you click that, you've locked in your answers. You can't make any changes. And that is what you need to do before Sunday at 11:59 p.m. Eastern time. Okay. Want to see if there are any questions about it. I will give some instructions.
Yeah, and also, Catherine, just feel free, during the weekend, if you're working it, feel free to Slack us. If you have any issues, we can, make sure that if you have any issues connecting to Codio or any issue what to do, we're here for you all. Hopefully you will not go running after Bill's amazing run through, which I personally got a little scared, I confess. But at the same time, it's like, wow, I'm going to learn to do all that. That's going to be awesome. Mm-hmm. So hold tight that we're going to get there. Don't run away.
Yeah, not yet. We're just getting started here. Riz, really great question. After clicking mark as complete, can you still go back and read the material? Absolutely. We're not going to lock you out of this material. What you get locked out of is just editing or modifying your answers. Now, can anyone tell me, are knowledge checks graded? Are we going to give you, yes, you got it right. No, you got it wrong. No, exactly. We are not going to actually grade it, sit there and say, hey, you got this part wrong. No, this is more so as a learning tool. I want you all to take this as a point where, like, when we pose a question to you, how do you answer it, right? See how you've been absorbing the material, right? This is a check for you all, okay? And you will have access to review it even after you've marked it as complete, just to even see your own progress. So please don't stress if you didn't get it perfectly right. That's okay. We just want to be able to assess your knowledge right then and there. Because if we don't, you might forget everything, right? So when we ask you questions, we're able to assess that. All right.
Catherine, I just wanna, sorry to kind of follow up a little bit, so they interrupt. When you said that, when it's locked, the question that they ask if you can come back and review the material, yes. But just so that you're gonna receive like a pop-up when you go back saying this material or this course, I can don't know the exact number, it's locked or whatever. Don't worry, just say okay, and you can go through and continue seeing it, okay? Don't freak out, don't stop, because you're gonna receive that pop-up saying that you already locked the answers on, or that it's already completed, or something around those lines, okay?
Thank you. All right. Okay, I know it is time, so I want to be mindful of time. All right, let me see here. Feedback regarding your knowledge check answer. If you want feedback, I think that's a perfect time for you to set up time with your TA to talk through it a little bit more, especially if you're unsure of it, right? Again, office hours will begin next week after a lecture. So if that's something, I would definitely write that down and make a note of it. Okay. So Michael, you do not need to upload any material. All you need to do is complete the knowledge checks from today. So go through all those slides and make sure all of that is done. Great question, Nelson. When is Monday's material available? So either by end of tonight, we will have released all the material for next week. So you can go ahead and review it, take a look at it. I would say please don't complete anything or mark it as complete, because wait until lecture to go through it and see if you need to change your answers, things like that. You can definitely type some answers, submit them, and then just make sure you don't mark as complete so you can modify them as lecture goes on if you want. Perfectly fine with that. All right. Alfredo, yes, you are able to access the knowledge checks in advance before class. Yes. What I will say though, and I just said this right now, is don't mark it as complete, right? It's okay to submit it so you can lock in your answer and modify it later, but I wouldn't mark it as complete because you haven't even heard the lecture yet, right? So Bill has a lot of amazing content that kind of goes really well with what you're learning here. So I'd wait to kind of absorb some of that, hear that, and maybe modify your answer as you see fit if needed. Okay. I like Nick's gift there. All right. Okay. It is time. And again, I want to be respectful of everyone's time. So we're going to call it here. I'm going to go ahead and post some of these instructions on the official announcements channel. We'll also let you know when the recording's available, and we'll let you know when next week material is available too. Okay. But I hope you all have a great night. If you do have questions, definitely reach out to your TA pair channels. You could also reach out to Donna, Alvaro, myself, and we're happy to help. But with that, I hope everyone has a great weekend and maybe has some pineapple pizza or not. So it was a very contentious debate there.
Oh, wow. I love pineapple pizza, pizza with pineapple, especially if it's like roasted pineapple. So
I don't hate it. I can't say I hate it. Awesome. All right, everyone. We'll have a great weekend and we will see you all on Monday. Take care. Bye.
yeah, post pictures of your pizza in
Yes.
Slack. Make sure.
Love to